in your folder, you just put the quiz away, the 51, you just put the notes away, 53. If you would, dig back out number 50. We're going to add to it a little bit. It's on a sheet of your own notebook. Thank you.
You just want me to add to this paper you gave me?
Yes, please. Right on the back would be great. We know all about ions. We all know about giving and taking. We know what molecules are, but there's a connection. Today we're going to see the connection. So there's some simple rules. Now, this is what we're going to use. Please don't need to write these green and blue down yet. But that's what we're going to use as our example while we're doing this. Thank you. So I would leave a gap, leave 2 lines, then write step 1 down, please. So look at the chart. What chart? The big one on the wall. That's right. We practiced making electron configurations. We practiced boxing. We looked at the last box and decided, is it full? We want it full. We want to have 8 in it. We said if it's more than half full, it's going to go ahead and gain some more. And if it gains more, it's a negative. And if it's negative, we call it anion. If on the other hand, that last energy level is less than half full, it's going to get rid of them. When you give something away, you feel positive about yourself. And if you're positive, you become a cation. So you know all that, right? You're experts. Brooke said, yeah, sorry, I'm an expert. I can do all that. So now that you're experts, I don't want you to, every time we do this, have to go through all those steps anymore. I want you to just turn your head left and look at the columns. So we're looking for fluorine and we're looking for magnesium. Where are they? Okay, so in this case, who's the cation? Magnesium is going to be our cation. Magnesium is going to be our cation, and fluorine's going to be our anion. So first of all, we have to decide which is what. Second step, we're going to write them down. We're not going to write the whole words down. We're just going to write the symbols down. And the cation always gets to go first. We'll look at the chart. It's on the left-hand side of the periodic table, isn't it? And when you read from left to right. So it just kind of makes sense that we're going to write magnesium first. We're going to leave a little space, big plus sign, and then leave a little space and write fluorine second, because cations first, anions second. The same order, left and right. You'll see them on the periodic table. Next thing, when you're looking at the chart, you look up. Danielle already did it. She said, well, hey, magnesium is in the plus 2 column. So you write its charge as a superscript. You put it up high and small. She said fluorine is in the -1. So we just did step 3. Next step. This is when you start thinking. Step 1, 2, and 3. We can probably teach a 3rd grader to do that, right? No insult to you intended. Look at the chart, find the letter, copy down the charge. Now, this is the reason you're in high school. You gotta think. So we're gonna decide, which do you need more of? And we'll explain that. Let's see what this means. We want the charges equal. We want the charges equal. Are the pluses and minuses equal right now? No. If this was a math equation, we have +2 - 1 equals what, folks? If this is a math equation, what's our total?
Hold on, let me get my calculator.
No! Plus 2 minus 1! You can't put that away, put that. We want it to be equal. We want this math equation to be 0. So, Candace, do I need more pluses to make this thing become 0? Or do these look like I need more minuses? Thank you. We need more minuses. So we have decided in this case we need more of these F minus 1s, don't we? Next step. Once you decided which you need, do I need more pluses? Do I need more minuses? Now it's how many more do I need all together? How many do I need all together? I emphasize this all together phrase. Thank you.
Wait, did you say
So,
that could happen?
we decided the minuses are behind. We need more of them. Brooke, how many more minuses do I need to make it equal 0? Plus 2 minus 1 minus 1 more.
I'll get you a calculator.
Brilliant. Thank you. So that, how please don't do that. Go back to where you were. So how many minus 1s do you need all together to
2.
make it even? You needed 2 minus 1s, which sounds weird to say it that way. Once again, after you practice it a little bit, it's just going to come
So you're trying to make
naturally,
it 0?
like breathing and swallowing.
Breathing.
Step 6. Coefficients. New word. Sorry, Candace. There's not many more steps. You've decided we need 2 of them. We need 2 F minus 1s. We need 2 anions to neutralize our 1 cation. And the new word is coefficient. Why is this doing this? It's coefficient.
How many more steps do
A
we have?
coefficient.
One more.
A coefficient is a number written in front. In math class, when you say 2x, the 2 is a coefficient. So we have superscripts up above, subscripts down below, and coefficients in front. All right, write the coefficients to the left. What's that mean to us? We go up here. You have decided we need 2 of these, don't we, all together? So I write a big 2 right there. That's called a coefficient. So that means I have 2 F minus 1s to start with. But what's really going on with that is, this magnesium wants to do what with 2 electrons? Is it going to give or take? Plus 2. What do I get to become a cation? What I give away. So what's really going on is this magnesium says, I have 2 electrons. I would like to get away so I can be more stable. And if that's not there yet, what can this 1 fluorine, how many can it take?
1.
It can only take 1 of them. It can only take 1 of the electrons. But I have a second electron I've got to get rid of. So if I had a second fluorine, he could take the second electron. That's what's really going on. These little duplos and stuff symbolize it. Now, this is nice. I really don't want to write F minus 1 2 different times. So instead of running it a second time, we fix this one. You put the coefficient in front and it says, I need 2 of those to start with. Last step. We've got the pieces ready. We got the atoms ready. Now we're going to symbolically slap them together. I'm going to make an arrow. I'm going to make an arrow. Point to the right. I'm going to write the new molecule. And I'm going to use subscripts this time. And that's all it is. Just fit on your sheet of paper, didn't it? Big moment! Now, finally, we're going to make the arrow. Do not make the arrow too early. Number one problem, people want to go ahead and make the arrow early and start on the right-hand side. Don't do any of that until you've done all this beforehand. Last step, we're going to rewrite the MG. It gets to go first again. It's always first. We're going to rewrite the F. It comes second always because it's the anion. I'm going to rewrite them. And see this 2? It is a coefficient to start with, but when you're done, it moves over here and becomes a subscript. And there are no charges up here. Why are there no charges? Because it's now neutral. There's nobody wanting to give away, there's nobody wanting to take. They wipe each other out. That's your final answer. Now, all that is probably way harder than it needed to be. Let's practice. Let's just say, hey, what if you had these two? I'm going to give you BEs. You're allowed to have berylliums, and you're allowed to have, we just did fluorine. Let's do chlorine. That's a Cl. I like you to kind of step by step. Find the charges, decide who goes first, decide who needs more of, and it's your first time by yourself. You'll be okay.
Oh, I see.
Now you got to indicate. Practice it, please.
Put the calculator away.
It's recording now.
Put it away.